Dear editors and reviewers, today I would like to give you a quick demo of our web-based implementation of the PIX2PIX-based daylighting prediction model. You can access the platform anywhere by visiting lettherebedaylight.com. Once on the website, you can choose which annual daylight metric you would like to use. In LEED option 1 for daylighting credits, ASE is the prerequisite for sDA. So let's start by testing the ASE. You can either try generating your own design by clicking the Open Room generator, or let's just use a sample file provided on the site. I'm going to choose the input 2 here. This design has two walls that have windows on them, and then I can change the orientation of this room by dragging it around, or I can simply change the input here. And then if I make the big window facing the south, and then I'll hit generate output, you will see that you will immediately get the ASE result, which is 30%, which is higher than the threshold required by LEED v5. If I lower the visible transmittance for the window here, you will see that the result went from 30% to 24%, which is improving, but it's not really working. Besides, in most of cases, you don't want your window has a very low visible transmittance like 0.2. This indicates that ASE is not very sensitive to visible transmittance. So in order to change it, what we can do is, first of all, we can rotate this around. For example, make it face the north, and then hit generate. Now you realize that the ASE result went from 24% to 1%. Even I increase the visible transmittance of the windows from 0.2 to 0.9, this result only went from 1% to 4%, which is still very good for the LEED v5 requirement. And then, since we have fulfilled the ASE result, we can try out the sDA. So I will click DA here and then generate the output of the DA heat map. At the same time, it will tell us the sDA is 97%, which is very good. The platform achieves sDA predictions with an R-squared accuracy of 0.96. ASE with an R-squared accuracy of 0.88. So as you can see that it's super efficient. You don't need to build a 3D model anymore. You can simply create your room with the interface here. At the same time, the result is actually quite accurate, definitely enough for most of cases in the early design phase. So thank you so much for your attention. I'm looking forward to hearing your feedback for our paper. Thank you so much.